Hello, my name is Elaine Palmer. I work for IBM's Thomas J. Watson Research Center in our Security Research Department. Today I'm going to talk about attestation of system components. It's a project within the OCP security project, and it is, we will go through how attestation fits into the grand scheme of an entire platform and its devices. So the agenda today is what problem are we trying to solve? What's our technical solution to this problem? What is attestation exactly? How do we use it? And how might you get involved if you're interested in working on the project with us? So starting out with what problem are we trying to solve? In cloud data centers, servers are filled with so many types of devices. There are subsystems, there's peripherals, accelerators, you name it. And each of those devices or subsystems contains hardware, it contains firmware. They come from all over the world, literally, and multiple suppliers. To add to that, these servers are typically configured on demand. So at any one point in time, the question is, what exactly is this server running? What combination of firmware, what combination of hardware is it running? So until the specification that the OCP security project came up with, the servers in a cloud data center had no standardized, open and automated way to dynamically establish the trust in and verify the trust in all of those devices. The footnote at the bottom says contract terms and conditions with trusted suppliers are necessary but not sufficient, because many of the trust mechanisms set up today, like how are these devices initialized? What firmware are they running? What version of firmware? What are the features that they have? Those are quite often done today contractually through supplier agreements. However, in a complex data center, we need to find out those things, not by reading contracts, but instead by some automated dynamic mechanism that the system can do to figure out what's in it. So what is the solution to this problem? So our solution is to enhance the security of all these devices and the platforms they reside in by adding secure provisioning and hardware protection of secrets and keys. We also insist on securely booting the device firmware, and we need attestation of the security state of the device. So those are the key parts of the solution to this problem: secure provisioning, hardware protection of secrets and keys, secure boot of the device, and attesting the security state of the device. So attestation, it's not a real common word, so let's go through what is it and how do we exactly use it here. So this is a picture of a farm. I am a fortunate person who has inherited a rice farm in southwestern Louisiana. And this is not my farm, but it looks very much like this. And when I inherited it, having been a computer person for my entire career, I had very little knowledge about farming and how things worked. And one of the things I learned was that if you want to get any kind of compensation from the government, every year you must file this form, CCC 941, with the US Department of Agriculture. And in it, you make an attestation, you the farmer or you the landowner, and you attest a fact that says, I certify that my average adjusted gross income for the last 3 tax years was less than or equal to $900,000. And that attestation, you say, you make a claim that this is so. And then you sign your life away and you sign your forms and send it in. That's the attestation. However, that alone isn't enough, right? The government doesn't necessarily trust you to make your claims correctly or be honest. You might make mistakes. So attestation, in order to use it, requires evidence. In this case, the evidence is, here are the my last three tax returns. And you, the government, you can use them to recalculate my average adjusted gross income to check me to make sure that I am attesting to the truth. However, that's still not enough, because I could give you fake tax returns. So the last piece you need to make attestation useful is that you actually need to verify the attestation. So in the case of the US Department of Agriculture, they can request a transcript, what's called a tax return transcript, from the Internal Revenue Service, and it reports your tax returns for some period of time. Using that and your claims, they can verify that you are indeed telling the truth. So there are three pieces. I'll go back. There's the attestation itself, there's evidence, and then there's verification. So how does this relate to cloud servers and devices? It actually does very much, because we do something very similar with devices before admitting them into servers. So the attestation evidence. Hang on. So the way this works with the security specification from the OCP group, security group, is that a device, when it wants to be entered into a server, also called a platform, it says, this is the device I am. This is the manufacturer who made me. This is the firmware I'm running, and may I enter the server? May I come in? And what it's offering is that it's evidence that it's okay. Specifically, we call that evidence the measurements. And the measurements are things like hashes of the firmware, the version number, and so forth. On top of the evidence, the device must digitally sign those measurements or its evidence when it reports that to the server. Now the server can respond. The server goes through a verification step, just like the Department of Agriculture verified the tax returns. The server says, let me make sure that I want to trust this device. First, it verifies the signature of the measurements, saying, do I trust this digital signature of the device? Do I know who it's coming from? And then it looks at the measurements and it says, yes, I expected you. I know who your manufacturer is. I trust your manufacturer. I see you're running the right version of firmware, and I will let you in. That's the happy path, as we say. You might get a different response. The device may get a different response from the server, and the response can be like this. I did expect you. I do trust your manufacturer, but you're running old buggy firmware, and go get yourself fixed and try again. But I'm not going to let you in yet. And another possibility is the server verifies the device's configuration, and it says, I don't know anything about you. I'm not going to let you in. You can't come in. So what does this look like from a technical or protocol point of view? So On the left, you see something called the reference repository. And that is, what is the expected state of a device? If you know what a device is, who manufactured it, you know what the firmware is, the level of firmware that you expect it to be running. This reference manifest is essentially a whitelist or known good measurements, and those have to be sent to the server, or what we also call the platform verifier. In the analogy with the farm, the IRS is the one that provides the tax return transcript that has all the actually submitted tax returns and the values for the last several years. Now, the server in the middle, or the platform verifier, then stores those expected values or whitelists away somewhere. And when a device wants to come in, which is over on the right, the attester device and its root of trust, it measures itself, and then it goes through a chit chat with the server that says, this is who I am, this is who made me, this is what I'm running. And the server collects everything about the platform, the device that it needs, and then verifies that. It verifies its identity, it verifies its security state against the reference manifest or the whitelist, and then it decides what to do with it. Is it going to admit it? Is it going to isolate it in a separate network? Will it remediate it by fixing its firmware, or will it absolutely just disable it and essentially shoot it and say, go away? So back to our analogy. In the case of the platform verifier, it is the Department of Agriculture or the U.S. Commodity Credit Corporation that decides whether or not the farmer or the landowner is telling the truth. In our device, it says, here I am, this is what I am, and the server has to decide whether it's telling the truth and what to do with it. Now, the specification in the OCP security specification has a whole section that is devoted to attestation. I've pulled out some of the table of contents here so that you can see what's in it. Of course, there's always the executive summary at the beginning, which is 1 page. Beyond that, we talk about the various types of keys, the seeds for those keys and random numbers, and device identifiers, and how those are generated and what they look like. We use digital certificates. Those certificates can be chained to each other, all the way hooking back to one root. And who issues those certificates? What are the credentials associated with those keys? In order to do, I showed you the high level picture of what's the big picture of the protocols back and forth. Let me go back here. This is a very, very high level of what happens. However, there are many other protocols and lots more interactions between and among the participants in the protocols. There's a provisioning facility set up. There's ownership provisioning. The server has to do discovery and interrogation of the device. And lastly, there's this authentication and attestation and enrollment protocol. So there are a number of protocols involved in establishing and performing the attestation required. We have a section on how do you collect measurements, what kinds of measurements should you collect, and where do you put them, how do you protect them. Now, in any kind of specification, in any standard, particularly in the case of an OCP standard, an OCP specification, we need to say, what is it that you need to conform to? What are the requirements if you are a device vendor or even so much a platform vendor, that you need to implement on your device in order to have an OCP compliant device. So in the specification, all of the requirements are documented. They are in this kind of type font that you can see, requirements. We cover a general conformance statement. What do you have to worry about for keys and entropy and randomness? How do you provision the devices in the first place? What kind of equipment do you need as a provisioner? As an owner, say the cloud provider that puts the device into service, how do you provision it? What does the server have to do to find it when it comes into the device? How does the device authenticate itself, send its attestation measurements, and how does it enroll itself into the system? There are more requirements, which is what should you measure, what should you not measure, and what is security relevant data that you need to measure. Let's go through this flow chart a bit on device provisioning. I won't go through the details because we don't have all that much time to go through the gory details. But this is essentially the beginning of life of any one of these devices and how it begins to get its identity and its keys and its firmware. So if we start off on the left, step 1, each device must have a unique identifier. It has to be absolutely unique globally, a unique device secret that is either generated securely inside the device by itself, or it's injected by the provisioning facility. Injection is not the optimal way to do it, but in some cases there's a preference to do it that way because if there are problems with the randomness, random number generator, there are ways through the provisioner to detect that. So different vendors choose different routes to get that first uniqueness and device identifier into the device. Once the device knows what its unique key is and its identity, it then asks the provisioner, please give me some credentials. Tell the world that I came from you. Tell the world that you made me. So it provides that key to the provisioner, and the provisioner takes the public key and issues a certificate to the device that says, yea, verily, in step 3, here are your credentials, here's your certificate. It will prove to the world that I did, in fact, create you. Step 4 says, okay, now that I know who I am, I need to be able to tell the world what are my measurements. So I need a key. I need a digital signature key that can then be used to sign attestations. So step 4 is create a key for me, again, done on the device itself, not injected. And then step 5 says, okay, now that I know who I am, I have an attestation key. Now the owner who puts the device into service needs to tell the device, okay, I'm the one that owns you. And if we're going to do any kind of updates to you, I'm controlling these updates. And lastly, the last step is the owner says, device, if ever you get any new firmware, it must be signed by the firmware signer. And so it injects a key into the device that says, only listen to this firmware signer. If you get firmware signed by any other entity, throw it out, ignore it. You can't accept it. So at that point, after step 6, the device has been totally provisioned. It's got its credentials that it needs to go forth in the world, and it can be deployed into a system. Now, I will spare you going through the protocols on this chart. However, in the specification, I mentioned that there are much more detailed protocols, than that very first one that showed the high-level protocol. These are examples of, on the left, how does an owner establish ownership of the device? There are certain commands and responses expected between the owner and the attester device, the attesting device. On the right, it shows how a device comes into a system and what the interactions are that say, okay, please join me. Please let me into your system. And the system says, maybe, tell me about you and I'll decide later. So we'll go through this chit chat. I'll send you a challenge. You must encrypt it or sign it and respond. And this protocol on the right is what happens in that situation. So there are multiple protocols in the spec, and you can read them without the eye test. You can see them up close in the specification. Now, again, I mentioned that the requirements are clearly marked in the spec. In addition to the bold face and the titles that identify them, we've also identified them in a blue highlighting, so you can go through the spec and find right away, spot them right away, what are the requirements. This is just an example of what the discovery and interrogation steps require. Now, this specification has taken a while to come out, but we still have lots more to do. There are things such as setting up policies. What should a device do? For example, if it doesn't like the attestation it got from a device, what does the server do? Does it throw it out? Does it fix it? What does it do? Does it put it on a remediation network? Does it take it anyway? Because different devices and different systems have different policies on what they should do in that case. We have another area of work, which is how do we change ownership? Quite often a device can be purchased by one entity, and then after it's finished, that company is finished with it, it may want to sell it to resellers. And in that case, it needs to relinquish its ownership and say, okay, nobody owns your device. Forget everything you knew except who made you, and just start over again. So we need to write a specification on how to do that. And there is another group within OCP, the Open System Firmware group, that has very much interlocking requirements that go with secure boot and attestation. And we need to actually make sure that those two specifications are really in sync with each other. If you want to look into the project, there's a website here for where the project main page is. There's a wiki that points to the latest specifications. The specification has been in draft form and will be submitted to the incubation committee for approval in April this month. The mailing list, if you want to get on the mailing list, you can subscribe here. And all of the OCP contributions can be found here at this site. There are white papers on, for example, on how to do ownership transfers, what design should be, for example, what a secure module is on a device, as in the Microsoft Cerberus design. There are other specifications that have been donated. So there are many ways to get involved, whether you're just observing, participating in a mailing list, or actually getting involved and rolling up your sleeves and helping us write the specs. We welcome all of those. And that's it. Thank you for your time. I hope you enjoy the conference. If you have a question there's a questions and answers section on the left. I think it's on the left. It is on mine anyway. If you want to post questions there, that's fine. If not, we can just go on to the next session. We had one of the earlier questions from Sylvia, which was, what are the recommended ways to keep a device out that fails attestation? It's pretty much up to, there's one of those policies that we talked about at the end, which is one common way is for your BMC to decide what to do. One way is hold the device in reset. Another way is to take the device and send it off to a remediation, connect it into a remediation network that can then go fix its firmware or figure out what's wrong with it and why it failed attestation. There's a comment in the chat here about the quality of the handouts. So the handouts are available to you. It's the same place where we have the chat. There's a tab that says handouts. If that's not good enough, then contact me and I'd be happy to send you a copy directly. But the handouts are right there and you can zoom them out. Also, if you want to look at the spec, the handouts give you a link to the spec, which you can see real clearly what it is that you're looking for in the protocols. The protocols are indeed iTest because there's so many steps and so much detail that we try to put in there. So if you look at the document itself directly, you can see the gory details. I'm not seeing any more questions here. Oh, wait, there is one. Is from Veron. Is peripheral echo station trending towards in-band or out-of-band interfaces? We have both in our in the security group, but I would say that it would be in-band. We're trying to do this over the regular buses that the devices are connected through. So you could do it either way, but I'd say in-band. We also have some members of the security project participating in the chat. I see that Yigal has been answering some of the questions. Thank you, Yigal. Oh, I don't see any more questions, so thank you all very much for listening and for your good questions. You can sign out now.